In this video, we will work through some problems requiring us to work with some equations. The principles we used before still apply. For instance, recall that the profit maximizing quantity for a firm in a perfectly competitive market is found where price equals marginal cost. Since price and marginal revenue are equivalent, this is the same thing as setting marginal revenue equal to marginal cost. This will be the key to solving our first problem. Suppose that a competitive firm's marginal cost of output is given by 20 plus 2Q. Assume that market price is $40. What level of output will the firm produce? Maximum profit is found where marginal revenue equals marginal cost. Since marginal revenue and price are the same thing, we will set price equal to marginal cost and then solve. We get a profit maximizing output of 10. Suppose the average variable cost is 20 plus Q, and the firm's fixed cost is $120. What is the firm's profit? Plugging the profit maximizing quantity of 10 into the average variable cost equation, we get an average variable cost of $30. This implies that variable cost is $300 when quantity is 10. Adding variable cost and fixed cost, we get a total cost of $420. Since revenue is $400, profit will be negative $20. What is the firm's producer surplus? Short-run producer surplus is equal to profit plus fixed cost, or $100. This is the gains from trade the producer receives from engaging in market exchanges rather than shutting down. Will the firm shut down and produce nothing in the short run? No, the firm does $100 better producing than it does shutting down. This is what the short-run producer surplus of $100 means. If the firm shuts down in the short run, its profit will be negative fixed cost, or negative $120. If it produces the profit maximizing quantity of 10, it will get a profit of negative $20. This is a $100 improvement. Again, this is what the $100 of producer surplus means. Suppose that higher property tax increases cost by $30. What will happen to the firm's short-run output? Recall that we determine the short-run output by setting price equal to marginal cost. Since price and marginal cost have not changed, the profit maximizing output has not changed. This underscores the fact that when economic actors like firms seek to make themselves as well off as possible, they make their decisions at the margin. If the averages or total change, but the marginal cost and marginal revenue do not change, then the optimum generally will not change. Now that the firm's fixed cost has gone up, it will have less profit, but the profit maximizing quantity will still be the same. In the perfectly competitive constant cost parsnip market, the market demand is Q equals 10,000 minus 100p, and the short-run market supply is Q equals negative 2,000 plus 200p. For each parsnip producer, marginal cost equals long-run average cost at $20. In this market, we would expect there to be blank until the market price is blank. This graph here depicts the situation. If you take the market demand and market supply and solve for the short-run market equilibrium, you will get a price of $40 and a quantity of 6,000. Recall that when marginal cost equals average cost is at its minimum. So the fact that marginal cost equals long-run average cost at a price of $20 implies that this is where long-run average cost hits its minimum. Since price is greater than average cost, economic profit is positive. This implies that firms will enter the parsnip market. The entry will cause the supply curve to shift right. This entry will take place until price is equal to the minimum of long-run average cost. This is where profit will be zero, and firms will no longer have a desire to enter or exit the market. The scenario here gives the total cost function, average total cost function, and marginal cost function for a firm that is in a perfectly competitive constant cost industry. At what quantity is average total cost minimized? Recall that when marginal cost equals average total cost is at its minimum. So here we set marginal cost equal to average total cost and solve for Q. So when Q equals 100, average total cost is at its minimum. What is the long-run competitive equilibrium price? In the long run, entry and exit drive firm profits to zero. Firm profits are zero when price is equal to average total cost. This happens at the point where average total cost is at its minimum, or at the point where marginal cost is equal to average total cost. We know this is where quantity is 100. So if we plug a quantity of 100 into either marginal cost or average total cost, we get the long-run competitive equilibrium price. Since the marginal cost equation is easier to work with than the average total cost equation, we plug the quantity of 100 into the marginal cost equation. When average total cost is at its minimum, both marginal cost and average total cost are equal to $20. So the long-run competitive equilibrium price is $20. If the demand is Q equals 12,000 minus 200p, and the short-run market supply is Q equals 300p, what is the short-run market equilibrium price? Setting quantity supplied equal to quantity demanded and solving, we get a market price of $24. What will happen in the long run? Since the short-run market price of $24 is greater than the long-run competitive equilibrium price of $20, we know that individual firms are earning a positive economic profit. This means firms in the industry are doing better than their next best alternative. This positive economic profit will attract entry. This entry in the long run will drive price down until it equals $20.